Hello, this video is on right-angled triangles. Specifically, it's on angles of elevation and depression, as shown here in the syllabus. You should already be familiar with using the three trigonometric ratios, sine, cosine and tangent, in right-angled triangles to calculate lengths and angles. You may be familiar with these trigonometry triangles, which can be used to help remember the ratios. Sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. When performing trigonometric calculations on your calculator, make sure that your calculator is set to degrees. To do this, from the main menu, select Run Matrix and press Shift menu to enter Setup. Use the down cursor to scroll down to the angle option and press F1 to select degrees, and then press Execute. The angle between the horizontal and your line of sight to an object is called the angle of elevation if you're looking upwards, and is called the angle of depression if you're looking downwards. Note that for two observers looking at each other, one in the car and the other on the building, then the angle of elevation and the angle of depression are equal. In this example, the angle of elevation of the ramp is found by using trigonometry. Identifying 9.7 meters as the hypotenuse, as it's the longer side and it's opposite the right angle, and identifying 1.35 meters as the side opposite the angle theta. Referring to the trigonometry triangles, sine is opposite over hypotenuse. So we write sine theta equals 1.35 over 9.7. Additionally, covering up sine in the triangle, we see that to find the angle, we need to divide the opposite by the hypotenuse. Using inverse sine to find the angle, from the main menu, selecting Run Matrix, pressing Shift and then pressing the sine button to access inverse sine, opening a bracket and pressing the fraction button, putting 1.35 in the numerator and the down cursor to get to the denominator, and putting 9.7. Pressing the right cursor to come back up and closing the brackets and pressing Execute to perform the calculation. So the angle of elevation of the ramp is 8.00 degrees, correct to three significant figures. In this question, we're asked to find the height of the tree. If we start by drawing a diagram, as shown, letting h be the height of the tree. We can use trigonometry to find h. Identifying h as the side opposite the 52-degree angle, and the shadow, 12.4 meters, as the side adjacent to the 52-degree angle. Referring to the trigonometry triangles, tan is equal to opposite over adjacent. Writing tan 52 is equal to h over 12.4. Rearranging the equation to find h. Additionally, if we cover up O in the triangle, we see that we need to multiply the tangent of the angle by the adjacent. Typing in the calculation, so pressing tan and then 52, multiplied by 12.4, pressing Execute to perform the calculation, given the value shown. Alternatively, we can solve the equation on the calculator. From the main menu, selecting Equation and pressing F3 for Solver. Typing in the equation in its original form, so pressing the tan button and then 52, Shift to access equals, and then the fraction button, and using the X variable button to represent H and the down cursor to get to the denominator, and entering 12.4. Pressing execute to enter the equation. Note that the number next to X is not the solution to the equation, as we haven't pressed solve yet. Pressing F6 to solve the equation again gives H equals 15.87. So the height of the tree is 15.9 meters, correct to 3 significant figures. In this question, we're asked to find the height of the building being viewed, given our answer, correct to 2 decimal places. If we start by identifying Thomas's angle of elevation, viewing the top of the building, which we're told is 55 degrees, and his angle of depression when viewing the base of the building, which is 18 degrees. In triangle ABD, which is right-angled at angle B, we can use trigonometry to find the length of AB. Identifying 6.5 meters as the side opposite the 18-degree angle, and the length AB as the side adjacent to the 18-degree angle. Referring to the trigonometry triangles, tan is opposite over adjacent. Writing tan 18 equals 6.50 over AB, and rearranging to find AB. Additionally, if we cover up adjacent in the triangle, we see that we need to divide opposite by tangent of the angle to find the length AB. Typing in the calculation, so from the main menu selecting Run Matrix and pressing the fraction button, and on the numerator putting 6.5, and then the down cursor, pressing tangent, and then 18. Pressing execute to perform the calculation, giving the value shown. So AB is equal to 20.0 meters, correct to 3 significant figures. Alternatively, you can solve the equation on your calculator. From the main menu, select Equation, pressing F3 for solver, and typing in the original equation. So pressing tan, 18, shift to access equals, and pressing the fraction button, putting 6.5 in the numerator, pressing the down cursor, and putting the X variable to represent AB in the denominator. Pressing execute to enter the equation, and F6 to solve the equation. Next, in triangle ABC, which is right-angled at angle B, we can use trigonometry to find the length of BC. Identifying BC as the side opposite 55 degrees and 20 meters as the side adjacent to 55 degrees. Referring to the trigonometry triangles, tangent is opposite over adjacent. Writing tan 55 equals BC over 20. Rearranging the equation to find BC. Additionally, if we cover up the O in the trigonometry triangle, we see that we need to multiply the tangent of the angle by the adjacent side. Performing the calculation gives the value shown. Alternatively, we can solve the equation on the calculator without the need to rearrange it. On the calculator, pressing F1 for a repeat calculation and scrolling up, pressing the tan button, and then 55, pressing shift to access the equals, pressing the fraction button, pressing the X variable button for the numerator, and scrolling down and putting 20.00 in the denominator, pressing execute to enter the equation, and F6 to solve the equation. To find the height of the building, we need to add the two heights together. So that's DB and BC, as shown. So the height of the building is 35.07 meters, correct to 2 decimal places. In this question, we're asked how much closer to the cliff must the boat move for the angle of depression to change from 4 degrees to 8 degrees. If we start by drawing a diagram and identifying the angle of depression, which is also the angle of elevation. Identifying a right-angled triangle, we can use trigonometry to find the distance x. Identifying 50 meters as the side opposite 4-degree angle and x as the side adjacent to the 4-degree angle. Tangent is equal to opposite over adjacent. Writing tan of 4 degrees equals 50 over x. Rearranging the equation to find x. Additionally, covering up adjacent, we see we need to divide opposite by the tangent of the angle. Performing the calculation gives the value shown. Alternatively, solving the original equation on the calculator, F1 to repeat a calculation and scrolling up, pressing tan and then 4, shift to access equals, and then a fraction button, putting 50 in the numerator, scrolling down and putting the x variable in the denominator, pressing execute, and pressing F6 to solve. When the angle of depression becomes 8 degrees, as shown, we can use trigonometry to find the distance y. This time writing tan 8 equals 50 over y. Rearranging the equation to find y. Additionally, covering up adjacent in the triangle, we see we need to divide the opposite by the tangent of the angle. Performing the calculation gives the value shown. Alternatively, we can solve the equation on the calculator without the need to rearrange it. Pressing F1 for a repeat calculation, scrolling up, pressing tan of 8, shift to access equals, pressing the fraction button, putting 50 in the numerator, scrolling down and pressing the x variable button for the denominator. Pressing execute to enter the equation and F6 to solve the equation. To find how much closer to the cliff the boat has to move, we need to subtract the two distances. Subtracting the value of y from the value of x gives the result shown. So the boat must move 359 meters closer to the cliff, correct to 3 significant figures.